Welcome to Master Mathematics in Minutes. Today's topic is about the interior angles of irregular polygons. And we'll cover a couple of examples on how to calculate angles of irregular polygons. And we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what are interior angles of irregular polygons? The sum of the interior angles of a polygon with n sides is given by n minus 2 multiplied by 180 degrees. And this relation is true for regular and irregular polygons. And we will consider irregular polygons in this video. Consider the first polygon with 6 sides. Now, because the sides of each of these polygons are different in length, this is an irregular polygon. And next we have a polygon with 7 sides. And once again, this is an irregular polygon because the sides are not of equal length. And lastly, we have an irregular polygon with 8 sides. Let's have a look at a couple of examples. In the first example, we're asked to calculate the angle x, and we're given a polygon with 6 sides. 1, 2, 3, 4, 5, 6. And we're asked to calculate this angle x. And this is an irregular polygon because the sides are not of equal length. So, we have a polygon with n is equals to 6 sides. And we're able to calculate the sum of the interior angles as n minus 2 multiplied by 180 degrees. And we will substitute n with 6. And that becomes 6 minus 2 multiplied by 180 degrees. And that gives us 720 degrees. And so we're able to calculate x as equals to 720 degrees, which is the total interior angles, minus 100 degree, which is that angle there, minus 121, which is that second angle there, and so on, minus 118 degrees, minus 125, and minus 92. And that gives us 164 degrees. In the second example, we're asked to calculate the sum of the interior angles of an irregular polygon with 20 sides. And so we have n is equals to 20, and so we're able to calculate the sum of the interior angles by applying n minus 2 multiplied by 180 degrees. And we'll substitute n with 20. And that becomes 20 minus 2 multiplied by 180 degrees, and that gives us 3,240 degrees. So, this relation holds for an irregular or regular polygon. In a third example, we're asked to consider an irregular polygon with 12 sides, and we're given the sum of the first 11 interior angles is 1,750 degrees, and we're asked to calculate the size of the remaining interior angle. And so, we have a polygon with n is equals to 12 sides, and we're able to calculate the sum of the interior angles as n minus 2 multiplied by 180 degrees. And we'll substitute n as equals to 12, and that becomes 12 minus 2 multiplied by 180 degrees. And that gives us 1,800 degrees. So the size of the remaining interior angle is 1,800 degrees, which is the total angle, minus 1,750 degrees as given from the question. And that gives us 50 degrees. In a fourth example, we're given the sum of the interior angles of an irregular polygon is 1,260 degrees, and we're asked to calculate the number of sides. So, we know that the sum of the interior angles is given by n minus 2 multiplied by 180 degrees, and that holds for an irregular polygon. And we'll set that to be 1,260 degrees as given from the question. And the intention is to solve for n. So we'll divide both sides by 180 degrees, so that becomes n minus 2 on the left, and on the right we have 1,260 degrees divided by 180 degrees. And we'll bring the -2 to the right-hand side, and that becomes +2. And we'll copy n down, and we'll copy this term down. And that simplifies to n is equals to 9. So this irregular polygon has 9 sides. To summarize, the sum of the interior angles of a polygon with n sides is given by n-2 multiplied by 180 degrees. And this relation is true for regular or irregular polygons. Irregular polygons have sides of length that are not equal. So, consider this visually. We have a polygon with 6 sides, and these sides are not of equal length. And we have a polygon with 7 sides, with sides of not equal length as well. And lastly, we have a polygon with 8 sides, and these sides are not equal in length. Thank you very much for watching. This is Maths Mathematics in Minutes.